Welcome to the Anthropocene.
The relationship between us and the planet is changing. We're no longer at its mercy. We have now become a major planetary force.
The fundamental elements of our planet have helped shape human history. But now, we ourselves are a force of nature to be reckoned with. Even in the wildest corners of the Earth, you can't escape our human influence. The question is, what does that mean for our future?
Despite the noise about uncertainty in the political arena,
warming will actually save lives, not endanger them.
Do I believe scientists? No!
the fundamentals of climate change have been understood by scientists for decades. To start with, there are naturally occurring gases, such as carbon dioxide and methane in the Earth's atmosphere. In themselves, they aren't bad. In fact, we need them in limited quantities to keep our atmosphere at just the right temperature for life as we know it to exist on Earth. But if we produce an excess of these gases, as we have, the temperature rises, as it has. If you want, you can replicate this effect yourself in a simple lab experiment. Here's how. Take two identical bottles and set them side by side. Put a thermometer in each bottle and seal them. Then run a hose from a source of CO2 into one of the bottles. Shine two heat lamps of equal intensity at equal distance onto each one. Within minutes, you will see the temperature of the bottle with the carbon dioxide in it rising faster and higher. The bottles are like our atmosphere. The lamps are like our sun. Most of the solar radiation reaching the Earth is absorbed by the surface and atmosphere, which in turn radiates energy out toward space as infrared energy, heat. Most of the heat energy from the surface is then absorbed by the greenhouse gases in the atmosphere and radiated back down toward the surface. The more greenhouse gases we create, the more heat is absorbed and sent back toward the surface to cause further warming. This recycled heat does more than bump up the thermometer. Warm air has the capacity to hold more moisture, and water vapor is itself a greenhouse gas. So there's even more warming, which means the planet's entire hydrological cycle, the water cycle, is affected. More evaporation, more precipitation, more extremes in general. For nearly 1 million years, the CO2 content of the atmosphere moved within a natural bandwidth. But during the Industrial Revolution, humans started burning fossil fuels in increasingly large amounts. In fact, now, that's around 7 billion of us, rely on carbon-based fuels for 85% of our energy. Humans currently produce around 35 billion tons of carbon dioxide every year. About 55% of that is absorbed by the ocean, land, and vegetation, while the rest remains in the atmosphere. Most of that excess comes from burning fossil fuels. and more than half of the emissions come from power plants and factories, while about a third comes from our various forms of transportation. If we continue the current trajectory, by the time our children reach middle age, the levels of atmospheric CO2 will reach twice that of our planet's long-time natural levels. That is why we're already seeing the temperature increase, and we're already seeing the consequences. 4% more moisture in the atmosphere above the ocean is enough to transition to a new normal. Dramatic weather events, floods, storms, droughts, fires, they're all happening at a frequency and intensity we've never experienced throughout human history. In other words, climate change.
This is the story of how one species changed a planet. The latest chapter of our story begins in England 250 years ago. Fueled by coal, then oil, several brilliant inventions appeared. They ignited the Industrial Revolution, which spread like wildfire through Europe, North America, Japan, then elsewhere. The great railways, then cars and highways, connected people across the globe. Medical discoveries saved millions of lives. New artificial fertilizers meant we could feed more people. Population rose rapidly. But this was nothing compared with what was to come. The 1950s marked the beginning of the Great Acceleration. Globalization, marketing, tourism, and huge investments helped fuel enormous growth. People swarmed to cities, which became even more powerful engines of creativity. In a single lifetime, the well-being of millions has improved beyond measure. Health, wealth, security, longevity, never have so many had so much. Yet 1 billion are malnourished. In a single lifetime, we have grown into a phenomenal global force. We move more sediment and rock annually than all natural processes, such as erosion and rivers. We manage 3/4 of all land outside the ice sheets. Greenhouse gas levels this high have not been seen for over 1 million years. Temperatures are increasing. We have made a hole in the ozone layer. We are losing biodiversity. Many of the world's deltas are sinking due to damming, mining, and other causes. Sea level is rising. Ocean acidification is a real threat. We are altering Earth's natural cycles. We have entered the Anthropocene, a new geological epoch dominated by humanity. This relentless pressure on our planet risks unprecedented destabilization. Our planet is vast. It's difficult to comprehend the scale. It's difficult, too, to comprehend the scale of humanity and the vast changes we've wrought in a lifetime. Population, production, and consumption have grown exponentially. Roads, railways, airlines, shipping routes, the digital revolution. We've created a globally interconnected society. Evidence is mounting, we've entered the Anthropocene. Humanity is altering Earth's life support system. Carbon dioxide emissions are accelerating. Greenhouse gas levels are unprecedented in human history. The climate system is changing rapidly. The Intergovernmental Panel on Climate Change assesses the risks and options for societies. Its latest report states it is extremely likely humans are the dominant cause of warming in the past 60 years. Without deep emissions cuts, it is likely Earth will cross the target of 2 degrees Celsius above pre-industrial levels, the target set by international policy. This could happen as early as 2050. If emissions keep rising at current rates, a 4-degree rise by 2100 is as likely as not. It's very likely heat waves will occur more often and last longer. The Arctic will warm faster than the global average. It's likely sea ice will all but vanish in summer within decades if high emissions continue. It's very likely sea level rise will accelerate. Cities and coastal areas are vulnerable. In general, wet regions are set to get wetter, dry regions drier. Monsoons are likely to become longer, their footprint likely to grow, and downpours likely to intensify. The acidity of the ocean has increased 26% since the start of the Industrial Revolution. The full consequences of all these changes on the Earth system are unknown. Humanity's carbon footprint is huge. Societies will need to adapt to climate change. The scale of change depends on decisions made now. Can we remain below 2 degrees? It is possible. But it is up to societies now to decide the future we want. For a likely chance of achieving the 2-degree target, societies can emit another 250 billion tons of carbon. We burn about 10 billion tons of carbon a year. At current rates, we will use this budget in about 25 years.
Here are some hard numbers on climate change. More than 40,000 heat records were set in 2012 across the USA. May 2012 was the 327th consecutive month in which the temperature of the entire globe exceeded the 20th century average. Now, what are the odds of that occurring? 1 out of 4? 40? 400? 4,000? Add 95 more zeros. 1 out of a number considerably larger than the number of stars in the universe. Arctic sea ice melts to a record low in 2012. Today's oceans are 30% more acidic. Carbonic acid, from burning fossil fuels, is dissolving the shells and bones of life in the seas. The atmosphere over the oceans is a shocking 5% wetter, loading the dice for devastating storms. Hurricane Sandy made that point, with a vengeance. Storms on greenhouse gas steroids will continue to get worse. Sandy devastated 5 Caribbean islands, New York, New Jersey, much of the U.S. Northeast, and several Canadian provinces. Over 170 deaths and billions in losses. Now, to understand global warming, we just need to understand a few numbers. The Copenhagen Climate Conference failed spectacularly. The big emitters, China and the United States, offered few concessions. Amid the chaos, President Obama took the lead in drafting a face-saving Copenhagen Accord that fooled very few. Copenhagen is a crime scene tonight, an angry Greenpeace official declared, with the guilty men and women fleeing to the airport. But the accord did contain one important number: 2 degrees. Copenhagen formally recognized the scientific view that the increase in global temperature should be below 2 degrees Celsius, and everyone agreed that deep cuts in global emissions are required. So far, we've raised the average temperature of the planet just under 0.8 degrees Celsius. But that has caused far more damage than scientists expected. Thomas Lovejoy. If we're seeing what we're seeing today at 0.8 degrees Celsius, 2 degrees is simply too much. Alice Bowes. 2 degrees represents the threshold between dangerous and extremely dangerous climate change. James Hansen. 2 degrees of warming is actually a prescription for long-term disaster. No more than 2 degrees. That is the bottom line. The second number we need to understand is 565 gigatons. Scientists estimate that we can pour roughly 565 more gigatons of carbon dioxide into the atmosphere and still have a reasonable hope of staying below 2 degrees of warming. However, carbon emissions keep growing by roughly 3% a year. At that rate, we'll blow through our 565 gigaton allowance in only 16 years. The third number is 2,795 gigatons, the amount of carbon contained in the proven coal, oil, and gas reserves. In short, the fossil fuel we're currently planning to burn. This number, 2,795, is obviously higher than 565. It's 5 times higher. We have 5 times more oil, coal, and gas on the books than climate scientists think is safe to burn. We'd have to keep 80% of those reserves locked away underground to avoid climate catastrophe. Now, we can have a healthy fossil fuel balance sheet, or we can have a relatively healthy planet. But now that we know the numbers, we cannot have both. So, can we fix this? We can. How do we go forward? Here's a new number: 1%. The Cambridge University Global Review, The Economics of Climate Change, said the cost of mitigating global warming is 1% of global GDP. Creating the infrastructure and capacity to decrease emissions and improve efficiency will cost about $790 billion per year. Is that achievable? Well, let's look at spending for fossil fuel developments. North America pipeline plans. Shell expansion in Canada and Qatar. Shell Arctic developments. Investments by major Russian companies. New oil refineries in Nigeria and Alberta. Chevron's development in the North Sea, Congo, and Venezuela. The purchase of reserves, investment, and exploration plans. But that's not all. The International Energy Association and the United Nations say 2008 fossil fuel subsidies were between $500 and $700 billion. In 2012, the Natural Resources Defense Fund says global fossil fuel subsidies are $775 billion. The Climate Vulnerable Forum report, published in September 2012, says annual climate change costs are $1.2 trillion, 1,200 billion, mostly in less developed countries. The International Energy Agency estimates oil importing countries will spend $2 trillion on oil in 2012, and in 2013, and 2014, and 2015. So, let's do the math. $4,280 billion, the cost to keep burning oil, divided by $790 billion, the cost to convert the world to renewable energy, equals... Now, what does this mean? It means the global cost of oil is more than 5 times the cost to abandon it. And we haven't even talked about the costs of coal. Nor have we talked about the hidden costs of fossil fuels. The U.S. National Academy of Sciences estimated illness due to fossil fuel pollution costs the United States healthcare system $120 billion per year. The USA is only about 4% of the global population. So what are the healthcare costs globally? 500 billion? 750 billion? More?
More now on our top story, Super Typhoon Haiyan.
Buildings have collapsed.
Hurricane Sandy crashing on shore.
When extreme storms occur, we want to know, did a warming planet turn a merely dangerous weather event into a disastrous one? Scientists disagree over whether climate change is affecting hurricanes now, and if you look at any one storm, it's not possible to know whether global warming had an impact. But looking at hurricanes over time and forecasting into the future, researchers see a trend. To understand why, it helps to know how hurricanes, called typhoons in the Pacific, form and grow. A hurricane is like an engine, and the difference in temperature between the sea and the upper air is the fuel. Warm, moist air near the surface rises into the cold, and as it does, more air rushes in to take its place. The warm air condenses, forming clouds and releasing heat that accelerates the process. As more air rushes in, the rotating Earth gives it a nudge, and everything starts to spin. In a warming world with warmer oceans, there will be a greater temperature difference between the sea and the upper air. That adds more fuel, so the engine produces more power. The storm gets bigger, and the winds spin faster. The air will also hold more moisture, which means a storm will produce more rain. And sea levels will be higher, so a storm surge will start from a higher baseline. Does that mean more storms? Not necessarily, scientists say, but there is likely to be more destruction. We can blame climate change for that.
Typhoon Haiyan in the Philippines should be another wake-up call for us. You know, if you look back over the last 30 years, we've suffered about $4 trillion in economic losses from natural disasters. 2.5 million people have lost their lives. And if you look at it on a yearly basis, in 1980, the economic losses totaled about $50 billion from all natural disasters. And in 2012, that number went up to $200 billion. So if you look at the proportion of those losses from natural disasters that is attributable to extreme weather events, it's about 3/4. So as much as $150 billion was lost in 2012 as a result of extreme weather events. The phenomenon of climate change has so far resulted in a rise in sea levels of only about 7.5 inches. But we know that the seas will continue to rise. Fundamentally, what's happening is that the Earth is processing water differently than it did before. And so what we're going to see is that the number of extreme weather events will increase. Now, Typhoon Haiyan was the most severe storm to ever hit the Philippines. You know, we talk about Category 5 events like this as once-in-a-lifetime events, but 2 occurred in the same region in a single month. We simply have to stop talking about them as once-in-a-lifetime events and get serious about tackling the root causes of this increased intensity and frequency. What we're seeing in the Philippines is what we see everywhere in the world. These extreme weather events have a huge impact, but they hit hardest for the poorest. What we saw was the complete destruction of homes that weren't in fact built with the best materials, and these were the poor people who were affected the most. You know, if we're to be serious about trying to end poverty and boost shared prosperity, especially for the poorest, we've got to tackle climate change, and we've got to get serious about keeping the rising of the temperature of the world, the rising of the oceans, to a minimum, or these extreme weather events will continue to pummel and hurt the poor the most.
Munich Re, a top reinsurer, links the rapid rise in North American extreme weather catastrophes to fossil fuel-driven climate change. Climate-driven catastrophes in North America have risen from an average of 50 per year in the early 1980s to over 200 post-2005. We cannot sustain such massive loss of life and property. Catastrophe costs are building every year in North America and around the world. There is one other number in the Climate Vulnerable Forum report: 400,000. Climate change contributes to the deaths of nearly 400,000 people every year. 400,000 people every year. Now we've done the math. Where do we go from here?
We know enough about climate change. It is time for decisions now. Coping with climate change. What does that mean? Climate has always determined how we live, and when it changed in the past, we adapted. So, what's new about adapting to climate change today? Shouldn't we focus on other challenges, such as education, unemployment, and economic development? Sure enough, the climate has always been changing. But the recent change, caused by our emission of gases such as carbon dioxide and methane that increase the greenhouse effect of the atmosphere, has happened in a much shorter time frame. As a result, the Earth is warming. This change in our climate is already leading to significant impacts. Glaciers are melting faster than expected. Sea level is on the rise. And it's very likely that droughts and extreme weather events like cyclones will become more frequent. These impacts destroy people's livelihoods and homes. They damage our infrastructure and disrupt communication and trade. Moreover, climate change is endangering development successes, and the poor and marginalized are often affected the most. Okay, climate change is evidently taking place. Whether it accelerates further depends on our lifestyle and economic activities. So, is it all about reducing carbon emissions? Well, even if we were to stop emissions instantly, the world would not stop warming immediately due to the amount of gases we've already emitted. That's why we must do both: reduce greenhouse gas emissions and adapt to inevitable climate change. But how exactly can we adapt, considering that the precise extent and form of climate change aren't known? Climate projections will never be able to predict the future with absolute certainty, partly because the way in which the climate will change depends on our decisions in coming years. But do we really need certainty to make decisions? No. We routinely make decisions based on experience, facts, or insights available to us without knowing exactly what the future will bring. And while we don't know everything about future climate change, we know enough to act. But what exactly do we need to do differently? Basically, we need to bear in mind both current and future impacts of climate change. Climate projections do not translate into concrete strategies, but they can serve as guardrails for planning. We should consider how development plans, policies, and projects might be affected by climate change, and to what extent these in turn make climate change worse. One possible consequence of climate change is precipitation pattern changes. These may lead to both droughts and extreme rain, sometimes in the same place. We should ask ourselves how a land use plan must be changed in order to remain flexible in reacting to future challenges. What adaptation measures can help to minimize effects on the local economy and people's livelihoods? Coastal megacities worldwide are threatened by the adverse consequences of sea level rise and extreme weather events. But what does an urban planner need to consider in order to make these cities climate resilient? What are the most suitable adaptation options? Clear criteria like urgency, costs, and political and social acceptance can help to prioritize adaptation options, such as flood preparedness measures, improvement of drainage systems, wetland restoration, and coastal management. Adaptation is a learning process. We all need to continuously improve our adaptation strategies, and making climate change adaptation a topic at all levels is important. There are many resources available that can support these activities, such as online information platforms like CI Grasp. we need to reduce greenhouse gas emissions and adapt to the impacts of climate change. And we must start acting today, together. Involve decision makers. Increase understanding about climate change. Create awareness about the need for society to adapt. These are important first steps. Preparing for possible things to come is much better than bearing the impacts of climate change without any protection. We know enough. Now let's adapt.
Fossil fuels cost us much more to use than to abandon. Lives lost, health costs, environmental destruction, and money. Our money. Over 5 times as much money. We can move forward. We can prevent climate catastrophe. We must get off fossil fuels, beginning now.
In fact, it's a truly humbling honor to be asked as an outside researcher and scientist to talk at an IPCC event just after a new report. I was given this title, but of course I was mean and I said I'll go for 300 years instead. And I'm not so much professor, I'm mainly edutainer at Gapminder, and we are an independent foundation that fight devastating ignorance with a fact-based worldview everyone can understand. This is from the figures, which are also characterized by a lot of acronyms that are hardly explained. That also shows that everyone was really into it. But I like when they put up sea level rise, so you can see there are different sources coming together, and then there is a line. It's very clear that the sea level is rising. It's very clear that the sea level is rising. And then comes, that's the easy part. Then comes the difficult part. That's the future. And here, you know, the scientists cannot predict what will happen because it depends on what we humans do. The general public, the politicians, and industry. If we try to avoid emitting more carbon dioxide, the best scenario is this blue line with its uncertainty here. It has an uncertainty there. And the red line is the worst alternative. There are several alternatives coming. And then it would go up like this, and it has its uncertainty. What's interesting to me is that these uncertainties are shown so clearly. And you can see that the uncertainties of the best and the worst are overlapping. It's really difficult. It's really difficult. So it may be that we do the worst, but still, you know, by some still not fully understood mechanism of the climate system, it won't be that really terrible. Or we do very good, but still things will get worse than we could have predicted, and we will be up here. Very interesting to think about this. And one thing also with these ranges, these are like 95% probability, something like this. It doesn't mean that it's absolutely impossible that nothing would fall outside. Perhaps the most dangerous is that there is 2 to 3% chance we will be above this line. And even 1% risk that we will be far above it. So as I read it, today the question, does human change climate, yes or no, that's over. That's over, that's set. The big question now is, how much will it change? How fast will it change? In which way will it change? And where will this and that happen? This is the big question for the future. The background of it was already back to Svante Arrhenius here, and then it came forward in this way. Now, this is all about humans changing their behavior and causing a line to rise and then spiral out of control. You've seen other lines like this. You've seen other lines. No, first about the size. How big is this? Well, this is the maximum land rise in Sweden, up in northern Sweden, Ångermanland. The land is rising with this much in 100 years. So what we tell Örnsköldsvik now, keep calm, the sea will stay where it is. Because you are rising and sea is rising. And then we could say, wasn't it worse than that? No, it's not so bad for Sweden, a sea rise of a meter in 100 years. But it's terrible for Bangladesh. See the problem? Even the climate change, which is the global sea level, I picked that because that will be the same all over the world. And in one country like Sweden, it means not so much. In Falsterbo, it's a problem, you know. I have a friend who bought a house too low there. And I said, you wasted your money, you'll never sell that house. But up in northern Sweden, it's no problem. Whereas in Bangladesh, you know, this is a catastrophe. This is a catastrophe. They have to build dam at an enormous cost. Now, you've seen these ones before. Here we are. Population back in the 1800s did not grow. Father and mother got 6 children. And why didn't population grow? Because 1, 2, 3, 4 died before growing up to become parents themselves. That's a myth that people in the past lived in ecological balance. Human beings have never lived in ecological balance. They died in ecological balance. Burying 4 of your children is ugly, tragic. It's not that this was a mistake by humans starting to burn coal and industrialize. It was a fantastic thing to do. It's just that we have to do it much better than we've done so far. Then population started to grow, not because they got more children, you know. They still got 6. This is when Swedish emigration to US, less died, and then it took off, and we became 7. So this is also a line rising like this. Is it out of control? Well, this is the number of children when I was born, less than 1 billion. Today, at the turn of century, I should say, 2 billion. Now, what do the UN specialists in demography say? They give one of this line as the probable line for this century. The other 2 I just made up. So one of this is the specialist, the other is mine to make a quiz for you. Do you think that the demographers say, the world number of children in the world will increase to 4? Hands up, how many think 4? How many think 3? It will slow down a little. How many think there will be no more children? It will remain at 2 billion. As one turns 15, another is born. One turns 15, another is born. Thank you. This is the result in the Swedish Gapminder Foundation. Not only show data, we also measure knowledge about the world. You had it slightly different. We asked UK. We did a big ignorance survey in Britain. Because this is the right answer. The number of children have stopped growing. We have reached peak child. It's complete consensus, and it's not known. We have great problem that things are not known. IPCC share this with demographers and other people, telling really how the world is. This is what's about to happen. In demography, we are almost now seeing the solution, which you unfortunately are not seeing at all in climate change. So we have almost reached a new balance. 2 parents on average get 2 children. This is what happened. In Europe, fertility rate dropped like this. In America, it dropped like this. And then it dropped in Asia. Asia is already down on 2.2. Bangladesh today have 2.2 children per woman. The Swedes think they have 5 or more. Yeah, it's sad. I cry, you laugh. This is what we know more or less. It depends on how fast this will fall, you know. The number of children stopped growing. The adults will continue to grow during a breaking distance of 3 generations. Then we will be 10 billions. And that's these 10 billions here. These 10 billions, or 11 billions, it may be also in Africa. 1 in Europe, 1 in America, 1 now in Africa, 3 new in Africa, 4 now in Asia, 1 new in Asia. That's the people who will share the resources and use the energy so that we can keep climate under control. And it may be 10 instead of 11, but it's this number we have to plan about. There's so many demography denials who think that we can stop at 8 billion. This is wrong. And this Does it mean that I say demography is more important than climate? No, it's the other way around. I show you how important it is to understand this climate report and the climate change. And what? The West Europe, the Old West, and North America will be less than 10% of the world population. 80% will live in Africa and in Asia. So what about the carbon dioxide emissions? It's like this. Sorry for the small fonts. Each bubble is a country here. The size is carbon dioxide emission. 1900, big bubble, United States and Great Britain. Most of the other, where we have data, were small. This one had $1,000, $10,000, rich this way, poor this way. 2 ton, 6 ton, 10 ton, 12 ton. US was already, and UK around 10 ton. And then this happened. Remember another line that keeps rising. That's China down there. See little China there? China has still not hit the level that US had already in 1900. And at the same economic level, they have distinctly lower emission. Size, however, is big, but there are many. There are many. And what we see today is very clearly that it's the sort of richer part of the world. We have data 2011 there. I have to go back. It's interesting, I had to go back to 2008 to have data for all countries. That shows how little effort still is done. We don't even have data, and we get GDP per capita every 3 months. So here you can see it's the countries in this end. Over here is almost nothing. So when Mozambique over here, somewhere over there, humbly say, I think we'll build a coal power station because we only emit 0.1 ton and we need electricity. No, everyone say. And Stockholm in Värtan is still burning coal this day to produce electricity. Just a kilometer from the Swedish Academy of Science. That's how much we have understood here. So what if I show you income distribution of the world? Here we are. 1970, $1 a day, $10 a day, $100 a day. This is Africa, this is Asia, America, Europe. It was a camel world. Can you see? A poor camel with 2 billion, a poor hump with 2 billions, a rich hump with 1 billion. What has happened to the camel? This happened to the camel. The camel died, and it was reborn as a dromedary. Asia is now in the middle. We can't understand the world as a developing world. This is extreme poverty. This is the start of the emerging economy. This is real emerging economy. These are the richest. I'll make it more simple for you. I'll take the income distribution, but just the 7 billion people from the poorest to the richest. This is how much oil they consume jointly per year. This is how much coal. This is how much gas. This is how much nuclear energy they produce. This is bio and hydro, nice ones. And this, what is coming, it's solar and wind. 1%. How much now, the question is, how much does the richest billion use of all this fossil fuel, the richest billion use? Half of it. What does the second richest billion use? Half of what's rest. The third richest billion, half of what's left. The fourth, now you know how it works in an unjust world. The one in the front of the line takes half of what's left. This is the income. This is the distribution of fossil fuel and of carbon dioxide emission. And nuke, well, it's over there. Bio and hydro, that's all over, because the poor one can only rely on that. And where is solar and wind? It's there. It's the hollow of the rich. I don't make joke about solar and wind. Those are the real potentials for the future, no doubt, especially solar. But it's very strange that people think they are so big already. They are really small yet. We haven't even started to tap the enormous potential of this. So these are the 7 million child deaths a year. The biggest ongoing problem in the world, extreme poverty. Much bigger today than climate change is today. But in the future it will change. That's why the children are dying. If you burn coal, you save children. Do you hear? You burn coal, you save children. The people only have fire, electric bulb, washing machine, and all these things over here. That's how it's divided, the resource used in the world. Now, economic growth will be like this. It's the richest 3 billion that is the problem. It's not about developed countries and developing countries. Forget that. It's the upper middle income countries, the top of the emerging economies. They will increase their fossil fuel. And they will go up to this level. Nothing will stop them, I think. Well, they may be so clever, but it's unacceptable for them why they should stop at a lower level than here. And then these ones will come here, and these ones will come here. And the richest one, I often hear them say, they look down from and say, oh, you cannot live like us. You cannot have so many babies. That would destroy the planet. I find it much more logical when people down say, here, we already have less children than you up there. It's only those over there who have many children. We here, we have less than 2. And who are you to tell us we can't live like you? You change first if you want us to do it differently. This just doesn't work. I travel the world. I hear the logic of scientists, of politicians, of media, of young thinkers. We have the problem here. This has to change. These are the new 2 billions that will come the next 40 years. They will come where there's very low emission. They won't do the big difference. So we think we have done more than we have, and we haven't understood how much we have to do.
We've set this chain in motion, but the truly cataclysmic changes can be prevented if we act now.
Carbon dioxide is not a harmful gas, it is a harmless gas.
The first step is to separate fact from fiction. This climate science is no longer a matter of opinion, politics, or dogma. So let's not let a few dirty energy companies fool us or slow us down. There are now increasing numbers of affordable, clean tech energy sources, all available to us in limitless supply. By embracing them, we will create jobs and improve the economy. The current climate crisis is reality. We can't wish it away. What we can do is cease the debate and the denial and move on to solutions together.
And over the last 4 years, our emissions of the dangerous carbon pollution that threatens our planet have actually fallen. But for the sake of our children and our future, we must do more to combat climate change. We can choose to believe that Superstorm Sandy and the most severe drought in decades and the worst wildfires some states have ever seen were all just a freak coincidence. Or we can choose to believe in the overwhelming judgment of science and act before it's too late.
We have shaped our past. We are shaping our present. We can shape our future. You and I are part of this story. We are the first generation to realize this new responsibility. As the population grows to 9 billion, we must find a safe operating space for humanity, for the sake of future generations.
We're at the beginning of a dramatic period of change. At the heart of it is the greenhouse effect, a global warming caused by the gases we release. The question is, how will the planet and our civilization respond to this change? For me, the best way to answer this question is to look back into the Earth's past. Which is why I've come to the coast of California.
There's something really strange going on in the ocean over here. The whole water looks as if it's fizzing away like mad. I've never known anything like it.
This promises to be an unusual dive. The point is to take me back to the last time the Earth experienced a rapid and extreme increase in greenhouse gases.
you look. Wherever we are, surrounded with bubbles. These bubbles are the key to unlocking one of the Earth's great events.
55 million years ago, the atmosphere went through something very similar to the changes happening today.
The bubbles are full of a gas called methane, which is leaking out of a fault line deep below me and heading up there to the atmosphere. It is the speed and intensity of bubble release that's a critical factor.
Today, only relatively small amounts of methane bubble out from seeps like this at the bottom of the ocean. But 55 million years ago, methane started to erupt from the ocean in massive quantities. No one is quite sure why it happened, but huge areas of the ocean would have been bubbling like this.
55 million years ago, these bubbles would have been fizzing out, they'd have been belching out. It would have had a devastating effect.
Methane is 20 times more potent than carbon dioxide as a greenhouse gas. And as it burst up through those ancient oceans, it led to sudden runaway global warming. That burst in methane levels 55 million years ago was the closest experience we've got of what continued global warming might bring. So what was it that happened to the planet during that ancient surge in global warming? And what did it mean for life? The answer can be found nearly 8,000 kilometres away, on the Svalbard archipelago. It's well within the Arctic Circle. 60% of Svalbard is covered in glaciers. It's a landscape dominated by ice. But 55 million years ago, it was rather different. The clues are in the rocks.
See what we got. Ooh, look at this. So I was hoping to find. These rocks are stacked full of ancient leaves. Look, that's a frond of a plant there. There's another one here. There's a stem. A branch is going out. These rocks are packed full of leaves. Gonna keep going. Look at this. Oh, would you believe it?
These fossil leaves originate from a time just after the methane surge in the oceans. They're from a distant relative of the beech, a broad-leafed deciduous tree. Some of these trees are preserved in the permafrost in other parts of the Arctic.
It's amazing. You can just imagine these falling down from trees onto an ancient forest floor. But I mean, today, you don't get trees here, you don't get trees like this for hundreds of miles. It just tells you that 55 million years ago, Svalbard was a very different place.
Following the methane surge in the ocean, global temperatures would have been 10 degrees warmer than they are today. It caused immense upheaval. Plants and animals were forced to migrate towards the poles. Back then, I would have been walking through a completely different landscape. subtropical swamps and forest. Less high Arctic, more Florida Everglades. It would have been inhabited by ancestors of creatures like the hippopotamus and the crocodile. The lesson from the Earth's past is that the world we know today can change out of all recognition simply by raising the level of greenhouse gases in the atmosphere. But the remarkable events of 55 million years ago offer another, more optimistic lesson for us.
Clearly this extraordinary warm period 55 million years ago didn't last, otherwise I wouldn't be dressed like this. The planet cooled, ice came to the Arctic. So what happened?
What happened was the Himalayas. The creation of this mountain range helped return ice to the Arctic. When the tectonic plates of India and Eurasia collided around 50 million years ago, the result was a mountain range that grew to become the biggest on Earth. In building the Himalayas, the planet unleashed its most formidable global cooling weapon: weathering. The process begins when carbon dioxide in the atmosphere is dissolved in rain and snow. This reacts with minerals in the rock to form a solution that's carried by rivers to the sea. Here, the carbon is absorbed by marine creatures. When these die, they sink to the seafloor, eventually becoming rock, locking the carbon away. Because the Himalayas were constantly rising, they were perpetually exposing new rock to the elements. This drew more carbon dioxide out of the atmosphere, cooling the planet, and eventually leading to the refreezing of the Arctic. So the planet had an entirely natural way of reducing greenhouse gases.
But there's one obvious problem, and that is it takes millions of years to build a mountain range, and we don't have the luxury of that sort of time.
Yet the lesson from history is not entirely wasted.
Burying carbon has long been the sole preserve of the planet, but there's no reason why we can't have a go at doing the same thing ourselves.
We are now developing ways to take carbon out of the atmosphere. One method is to stimulate the growth of immense blooms of algae that use photosynthesis to draw carbon dioxide from the atmosphere. On land, there are plans to create artificial trees that replicate photosynthesis. But the biggest challenge is to stop carbon dioxide reaching the atmosphere in the first place. This can be done by capturing it at source, filtering it from industrial chimneys, and then burying it. Scientists are planning to try this out on Svalbard. If you happen to have thousands of tons of carbon to dispose of, the geology here is particularly helpful.
That cliff behind me is a layer cake of sandstone and shale, and that arrangement is perfect for burying carbon. This sandstone is ideal for storing the carbon because there's lots of spaces in the pores between the grains. And this dense, impermeable shale provides the ideal lid, which stops the carbon escaping upwards.
The plan is to drill a number of shafts through the dense shale lid and into the sandstone. Carbon dioxide will then be pumped down into the sandstone, where it will be locked within the pores of the rock. Carbon capture won't solve our greenhouse gas problem, but it might at least buy us some time to develop cleaner forms of energy.
Burying and locking away carbon is an attempt to accelerate massively what the Earth has done for millions of years. It's the beginning of a new approach to the planet, deliberately transforming it to try and preserve the conditions for our survival.
Up until now, the effects of our impact on the planet, whether good or bad, have been accidental and unintended. Whether it's a mud volcano in Indonesia or altering the Earth's climate, we never set out to create these changes. Science has given us an understanding of how the planet works that allows us to protect ourselves against Earth's unpredictable nature. But today, we're on the brink of a new era. We can now take control of our impact on the planet's natural processes and maintain the conditions for civilization to flourish. It's a big challenge, which involves global cooperation. But there's an example of what can be achieved here in Svalbard.
You know, you'd never know it, but locked inside this mountain is something incredibly precious. And that's the way in. It's got a front door. It looks like something out of James Bond.
To protect its contents, this facility in Svalbard has been built high enough to be above any future rise in sea level. It's been excavated so deep into the mountain that it would survive a nuclear explosion. This is apocalypse planning for our future survival.
You know, this is a giant vault, but in a way it's the modern equivalent of a Noah's Ark, except that instead of sheltering animals, it's preserving the future of the world's food supply.
The temperature is a constant minus 18 degrees Celsius to protect the precious content stored here. This is a shrine to over 10,000 years of agricultural development. It's a global seed vault.
I mean, take this. This is rice. But the thing is, there's not just one variety of rice in here, there's thousands, with different properties and different growing conditions, different resistance to disease. This is the genetic diversity of rice for the future.
But of course, it's not just about rice. This vault will one day store every variation of every staple crop from every country on the planet. It's a heck of an insurance policy.
You know, for me, preserving these seeds with all their precious genetic code makes a really important point. And that is, we're taking conscious control over an uncertain world. And in that sense, this whole place is like a symbol of what can be achieved at a global level if we put our minds to it. As a species, we like to think that we're special. Well, this is our chance to prove it.